Math 3, Semester 2, Mastery Exam Review, Power Standard 7. f of x equals 1 over x is shown below. Use the transformations to graph g of x on the same grid, and then say all of those key features. So, the plus 4 makes us go left 4, and then the minus 2 makes us go down 2. So on our graph, we normally have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So I'm going to move my asymptotes over first. So if I need to go left 4, I just draw my new vertical asymptote at x equals negative 4 right here. So I'm going to go ahead and answer that question. Vertical asymptote is x equals negative 4 since I had to move to the left. For the horizontal asymptote, I had to go down 2. So it should be right down here at y equals negative 2. Then, as far as the new graph goes, normally I go 1 point to the right and 1 point up from the intersection of the two asymptotes. So for example, my new origin is kind of right here at negative 4, negative 2. So that's kind of what I'm going to call my new origin. So from my new origin, I'm going to go right 1 and up 1, like that. And then let me zoom in a little bit here. I'm going to just try to draw in the curve so that it approaches the purple and red asymptotes, but so that it doesn't actually touch them. And then again, from my new origin, negative 4, negative 2, I'm going to go to the left 1 and down 1. And then I'm going to try to draw in another curve that approaches the asymptotes but doesn't actually touch them, like that. So there's your new graph. And then as far as the rest of the key features go, domain is always your x's, little to big or left to right. So from the left, I have negative infinity. Whoopsies. I have negative infinity over here, and I have positive infinity over here. So from negative infinity all the way up to my vertical asymptote of negative 4, that's the first part of my domain, and then union, negative 4, comma, infinity. So I'm just listing out all the x's from left to right, but I have to have a break in my domain at negative 4 because that's where the vertical asymptote is. As far as the range goes, range is always your y values, little to big, so bottom to top. So negative infinity, all the way up to my horizontal asymptote of negative 2, union, negative 2, all the way up to infinity. So you have all your y values except negative 2, because there's a horizontal asymptote at negative 2. If you get confused with domain and range, remember it goes in alphabetical order. X comes before Y in the alphabet, D comes before R in the alphabet, so that can help you remember which one's which. For that last one, part E, if you're looking for a y-intercept, it means you have to be on the y-axis. So if you're on the y-axis, you haven't moved left, you haven't moved right, so x has to be 0. So I'm going to take my original equation for g of x, and wherever I see an x, I'm going to plug in a 0. So like this. So 1/4 minus 2. I'm going to put the 2 over 1 to make it look like a fraction. And then when I'm subtracting fractions, I have to have a common denominator. So I'm going to multiply by 4 over 4 in order to make this have the correct denominator of 4. So then 1/4 minus 8 over 4 equals negative 7 over 4. And then we want to write our final answer for a y-intercept as an ordered pair x comma y. So 0, comma, negative 7/4. Number 2, they want us to just say the transformations that have happened from f of x to create g of x. So this 1/2 in the front is a vertical compression by a half. If the number, the a value, is in between 0 and 1, it's a vertical compression. If the a value is larger than 1, it's a vertical stretch. The negative 3, since it's under the radical sign, that's a horizontal translation, and the horizontal translations are always the opposite of what we think they should be. So since we see a -3, it's actually right 3. So horizontal translation, right 3. And then the +5 in the back is a vertical translation, and those are as they should be. So up is positive and down is negative. So since it's a +5, it's up 5. And that should be it for that one. 3, same question, but then now slightly different transformations. And you'll notice the parent function, the index on the parent function matches the index on the transformed function. So for example, this little tiny 3 matches this little tiny 3, and that's as it should be. And then back on number 2, let me switch colors. This little tiny 4 matched this little tiny 4. So that's as it should be, because it's the same parent function. So on number 3, the negative sign in the front is a reflection over the x-axis. The 2 is your vertical stretch, because if your A value is larger than 1, that's your vertical stretch, as opposed to a vertical compression. So vertical stretch of 2. And then inside the parentheses, this +1, let me get a slightly different color here. This +1 makes us go left 1, because your horizontal translations are always the opposite of what you think they should be. So horizontal translation left 1, and then that -3 in the back should be down 3, because your vertical translations are always as they should be. So vertical translation down 3. On number 4, we have this negative sign under the radical, so that's your reflection over the y-axis. And then the 4 should be a horizontal compression, because it's under the radical. Horizontal compressions and horizontal stretches are always the opposite of what you think they should be. So if the B value, which is the 4 in this case, if it is larger than 1, then it's a horizontal compression by a factor of 1 over B. And then if the B value is in between 0 and 1, then it's actually a horizontal stretch, still by a factor of 1 over B. So that 4 is representing a horizontal compression by a factor of 1/4. And then the +9, we like those, that's easy, just up 9. So vertical translation up 9. That C in factor is really bothering me. Slightly better. Number 5, consider the function f of x equals x to the 6th. Write the domain and range of f of x in interval notation. So it's helpful in this problem, I think, to draw yourself a little sketch. So x to the 6th looks a lot like x to the 4th, which looks a lot like x squared. Usually, the only big difference is that it gets a little bit more flattened out towards the origin. So it looks something like that. So your domain is all real numbers, so -infinity to +infinity, and then your range is all your y values, so 0 to infinity. Because remember, domain is x's, range is y's. For number 6, they're still talking about that same function, x to the 6th, but this time they are restricting the domain to all the x values that are greater than or equal to 0. When that happens, we get an invertible function. So they want us to write an equation for g inverse of x, which is the inverse of the function. So remember, with inverses, you let g of x equal y, because those are essentially the same thing, just a notational difference. And then your first step with finding an inverse is switching your x and your y like that, and then you're supposed to solve for y. So the only way to get rid of something raised up to the 6th power is to take the 6th root. And normally when we introduce a root into an equation that has an even index, normally we add a plus minus symbol, But because of the fact that we restricted the domain, we're not going to add the plus minus symbol on our answer because that'll mess up the fact that we're trying to make the inverse function a function. And then if I want to go with the fancy notation, instead of y, I want g inverse x equals the 6th root of x. So then that would be our answer. Part B, write the domain and range of the functions g of x equals x to the 6th when x is greater than or equal to 0, and g inverse of x in interval notation. So if I look at my graph back up here, let's just look at the correct domain. So they said the domain is going to be x greater than or equal to 0. So I'm only looking basically at that part of the graph for g of x. So my domain would be 0, infinity, which again, that's basically this written in interval notation. And then my range should be the same thing. It's all my positive y values, but also including 0. Now for the inverse function, since you switched your x's and y's, you actually switch your domain and range. Since everything happens to be the same anyway, when you switch your domain and your range, you get 0 to infinity for everything. Because, again, let me draw some arrows here. The domain of the original function becomes the range of the inverse, and then the range of the original function becomes the domain of the inverse. Sketch the graphs of each one. So we already know the first one looks like what I had sketched up above, but it's only when x is greater than or equal to 0. And then the inverse is supposed to be what I get when I flip the graph over the line y equals x. So it should look something like this. If you are really struggling to visualize that, what I would recommend doing is just doing a small little t-chart. So for example, x and g of x, although I should make the colors match so we don't get confused. So x and g of x, and then for the blue one, x and g inverse x. So again, my domain is restricted, so I can't have any negative x values. So when x is 0, I have 0 to the 6th power would just be 0. 0 to the 6th power is 0. And then when x is 1, 1 to the 6th power would be 1. And then when x is 2, 2 to the 6th power is, I think, 64. Let me double check that, make sure I'm not making that up. So 2 to the 6th power, 2 to the 6th power, yep, 64. Just making sure I wasn't making that up. 64. So then when you do inverses, remember you just switch your x and y values. So 0, 0, 1, 1, 64, 2. So if you needed that to kind of help you get your graph a little bit more accurate, use that to help you get your sketches of your graphs. And notice how I had to label both of my graphs. And then I believe that is it. Yep.